thank you everyone for coming. Welcome to this talk. My name is Maria Gomez. I'm the head of technology for ThoughtWorks in Spain. And in the next 35 minutes, I'm going to be talking about how to apply continuous delivery practices and techniques on the world of connecting devices, IoT, and embedded software. So before we got into the all the nitty-gritties, we are going to be just giving some context, just going back in history a little bit and talking about the history of continuous delivery very briefly. So the continuous delivery book was published in 2010, and Jeff Campbell and Dave fairly kind of define continuous delivery as the ability to get changes of all types into production or into the hands of the users in a way that is safe, quick, and sustainable. And those three things are very key because as a business, you should be able to create a process that's care to your needs and allow you to deliver value to your customers. And this thing, continuous delivery, now seems like a lot of common sense to us, but it wasn't the case for a long time, and still some organizations are following a very waterfall approach where we kind of divide everything into phases, and one phase needs to be finished before the next one starts. And we see that if something goes wrong, or when something goes wrong, because obviously no one can predict the future, then that means that a lot of rework needs to be done because the system at that point was probably fully developed, and then changes are very costly. What we think with agile and the whole new way of looking at software delivery and software development, we saw that organizations and teams are starting to get very, very good at iterating through requirements and identifying small pieces of functionality that were delivering value and iterating through them. So we have a lot of teams working on agile, or these agile teams that are really good on creating that environment or creating that fast feedback and being able to deliver value in a way that is consistent and they're confident with what they're delivering and stuff. But then they start to hit what is called the last mile, which is all of these other steps that will slow you down when you actually want to go to production. So those can be QA processes that needs to be that needs a fully integrated system that's belong to a different team that lives in a different building or in a different country. And those can also be, the act of deploying the software and maintaining the software in production, that sometimes that belongs to another different team, a SysOps or an operation teams, and developers or people building that software or that products. Sometimes you feel like we are just throwing the artifact off the fence and someone else will pick it up and deal with it. So continuous delivery talks about moving all of these activities that are part of this last mile into the beginning of the process. So creating cross-functional teams that can and are responsible for the whole life cycle of the product. And that will allow you a constant flow of new features into production, right? Organizations have been for many years. Software delivery companies, organizations building products with software have been for many years working towards this type of environment when we have this very nice way of delivering value. But what happens when that organization also has a hardware component? What about if we are building embedded software and we are also building the hardware that is gonna be running the software in there? How can we make sense of continuous delivery? We have this many different connected devices of different nature and different life cycles. So I'm a software developer and not a hardware expert and not embedded software developer neither. What I am, though, is a continuous delivery expert. I've been working, helping organizations to be better at how they deliver products for the last 7 years. As I said before, I work at ThoughtWorks, and this is also what we do. So Last year, we had an organization who came to us. That organization creates all of these connected devices and all of these interactive experiences. And they ask us to help them to improve their processes and to reduce their time to market. We're talking about people who will take months and months to prove something, and not just delivery, that even takes even longer, and they wanted to reduce it to weeks. Because in order to keep up with like the fourth industrial revolution, with all the innovation that's happening in the IoT space, they felt that they needed to improve the way they were building software and the way they were integrating the software with the hardware that they were also building. So this is what I'm going to be talking to you in this talk, the things that we learn, the things that they learn from us, what are the techniques that we apply to help them in that journey. So to give you a bit of context, the specific project that we worked with them was they wanted to create an interactive experience for passengers of a car. So every passenger sitting on a car will have a tablet next to them, and with that tablet they could control things like, the volume, the music, the windows, the temperature, things that were obviously not critical for the car. So the way that was doing is that tablet was connected to a box that was running a Linux distribution, and on top of that there were a bunch of applications that were holding all the logic that will say, this tablet is asking me for this song, so I'm going to call the music system in the car, and I'm going to tell it to play the song. That communication was done through LIN bus. LIN bus, or LIN, is a network protocol that is used in cars. And I guess I have to say, when we got into that company, they were in the development phase of all of this. So what they really wanted is a way to speed up all the development process so they could test and validate the assumptions and the hypotheses that they were making. So we say, okay, so let's look at continuous delivery, and how we can do this with you. So continuous delivery is a lot of things, and I like this representation because it shows you how non-trivial and complex it can be. So there are many things and many aspects that a company or an organization needs to work on before saying that they are delivering value in a continuous way. I'm going to go through a few of them, not all of them, only the ones that I felt that were more important and relevant for this topic. So the first one is architecture, so technical architecture. Software architecture or architecture is defined as the important stuff, whatever that is, and that was a definition by a very well-known computer scientist. And in in the context of continuous delivery, architecture means what is the end state that we want to have, roughly? What are the type of abstractions that we want to have? What are the cross-functional requirements that are gonna kind of shape those abstractions and that architecture, and how we are gonna test that we are doing the thing that we were expecting to. In software, we are talking a lot about evolution and how we can design and look at architecture that will help us evolve, and they will be able to embrace change instead of being very rigid. So that's very important for us. And we also talk about cross-functional requirements, as I said before. So what are the other things that are also going to help us pivot or move from one direction to the other? So is it security? Is it data privacy? Is it performance? So all of those things will change over time also, and that will make us change the way that we are designing our systems. And this for software is kind of interesting and still difficult to do, but for hardware it can be even more so. If we are talking about the new world of connected devices, we are looking at architecture that in a nutshell might look something like this. So we will have a set of devices. Those can be inside a house, those can be inside a car, like in the company that I was working with. And all of those devices will be connected with each other, maybe, and they also will be connected to some kind of backend system that will orchestrate how they function. And then there will be some kind of user interface, so people can actually interact with these devices. And if we talk about also building the software itself, then that means that we also need to look at what are the layers within that we are also going to be evolving as we know more. So and that's the difficult part, right? In software, when we look at evolution, we talk a lot about the last responsible moment. That means that we will delay certain decisions until we know more. So we don't know still what type of data we're going to be handling. So we don't want to make a big investment on a database that might not be appropriate. We prefer to delay that decision for a number of weeks, do some spikes, and kind of clarify that, and then do the decision when we have more information. Maria, in 6 months, will be smarter than Maria right now, or at least that's what I hope. So the last responsible moment with hardware is kind of difficult because in some of the cases, you want to start building the hardware that you're going to be using later. So making a decision, it has, I guess, a more durable and tangible consequence. Because you can't, you could do rework on boards and stuff, and people do that, obviously, but all of that required a lot of investment on time and a lot of investment on money, right? Or even if you are not even building your own hardware, but you are buying sensors or devices, all of that will be quite expensive. So what can you do to kind of prove your technical assumptions? There's something called digital twins, and those are well known within the hardware industry. And with the the fourth industrial revolution, IoT, and all that stuff, they've been even more widely known right now. Gartner, who is a company that spends their days doing market research, said that digital twins was the strategic technology trend of 2017. So something to look and investigate. And basically, a digital twin is just a mock of a physical device. So, you can go really simple and say, I'm just creating a very simple API or a very simple service that will mock that API that I have with that device, so I can start building software against that API. Or I can go very, full on and buy a software product that will help me simulate a whole plant. NASA, when they design and build rockets, they don't start building the rockets. They use very big simulation software and very powerful that will help them prove their assumptions. So the same thing with this, right? So how can we use technology to actually, and something that is far, far cheaper, to actually prove our architectural decisions. Another thing, obviously, that you can do is if you are going to be using hardware that you are going to be building or you are going to be changing from its original form, you can also just use development kits that all of the providers of those boards will give you. You will pay for them, but you can give them. So in our case, we were using that. We were using two development boards, and we were proving our assumptions through them. And that will also help the hardware team to identify how they need to change or shape the new requirements. The next thing is quality assurance. So how can we be confident that what we are building, software and hardware-wise, is working as we expected? How can we automate that confidence, and how can we bring it to earlier on in the process? And by testing and by quality assurance, I mean everything from unit testing the code that you're building, even the one that is going to go into a board, to testing the whole thing in an end-to-end test or an integration test, right? So there's no excuse for not writing any test, any unit test in any language. C++ has amazing testing frameworks, and C also has it. So, and if you are doing you're using sensors, IoT, or more off-the-shelf devices, you will have some kind of, as we said before, some kind of backend service, to control them. So that will be written in a language that can be tested. So this is definitely that. And also, you can start to think how you can do system-wide tests or integration tests. If you're using a digital twin, that's going to be fairly easy because you just be testing against a mock API. And if you're using the physical device, or when you have the physical device, you really just need that device to be connected to a computer or to have an internet connection for you to be able to run and write an integration or an end-to-end test. In our case, we managed to run end-to-end tests by doing that. We have 2 boards, one for the tablet and one for the box that was in the middle. And we had them connected to a computer, and we have a stage on our Jenkins pipeline that was actually connecting to those and running certain tests. And that was fairly straightforward to do. And in a combination with whatever you're using, a digital twin, or you're using these development kits, you can really, the key is that you can really speed up your development, and you can start proving those assumptions very early on. And not just technical assumptions, but also business ones, right? Functionality. How is this system supposed to behave? Is it making sense for the user? The next one is continuous integration, because we couldn't talk about continuous delivery without continuous integration. Continuous integration basically is I write some code and push that code to the master or the integrated or the common branch. And then there are some tests that run on that branch, on that master branch, and then I get the feedback. And I do the same multiple times per day. That's it, right? Because it wouldn't be a continuous delivery talk without a reference to Martin Fowler. There you have the reference. So that's a continuous integration certification test that Martin has, which he basically talks about the process that you follow in continuous integration. So if you are a software developer like me that has been all your life building web apps or backend services, you kind of get this idea. You understand what continuous integration is, the value, and you know how to write tests. But other developers, for example, those working on embedded software, not all of them have that exposure, right? So a lot of them are used to work in branches for weeks or months at a time. They're used to test their stuff very manually, and also the tools were not available, that long ago to actually start automating some of this testing. So for us, that was actually really, it was a challenge to show and demonstrate the value of these practices, and to also help the team to become more autonomous and to understand how to write tests and see the value of it. But the great thing was that we were able to have a continuous integration pipeline very, very quickly, because at the end, you have a bunch of code, it needs to be pushed, and it triggers a Jenkins job or a pipeline that just runs some unit tests, so that was really, really fast. And that gave us some momentum, and that gave us the opportunity to start having different conversations, pairing with the developers to actually teach them and help them to write those tests. We weren't 100% successful. There were some people who really didn't like this approach, but what we got was people who were really motivated to this, and that allowed us to not just help the overall team, but we also help other teams outside, because these people were they were basically talking to each other and talking to other people in the organization and telling them how good was this and all the value that they were getting. So now that we have continuous integration, our continuous integration loop, the next thing in our continuous delivery journey is to actually, get a pipeline that allows us to deploy this into different environments, do certain tests, and also deploy it to what we can call production, right? So again, for a pipeline, a deployment pipeline or a path to production can be something as simple as this. when you have very linear set of environments that they can, and you know and understand what are you testing in each one of them. Or it can be something a bit more complex, where you have different artifacts and systems that come together to build a final product. I think what is important is that from the get-go, you start drawing that picture of your path to production. Even if nothing is automated, that's fine. But at least you will understand what are the steps that will take you and your team to write one line of code or to fuse something into the board until that chain is ready to be used by a customer. And once you have that picture, then you can start looking at what are the things that we can automate, how can we automate them, what are the processes that we can improve or eliminate because they are not useful, and what are the things that we can do to just get a better pipeline and reduce the times. This is the path to production of the pipeline that we had. So really big. That we have, I think this is for like maybe a month after we started. So we had the pipeline defined, very early on. This is kind of the state when it was like a month into the development. So as I said before, this project had two main components. There was a tablet or an Android tablet, and then it was a box or a set of Android tablets. Those Android tablets were running their own version of Android, so there was a customized ASP, and the box was running its own version of Linux, a Linux distribution. So, and then there were certain apps that were going to be installed in the tablets, and then certain applications that were going to be running on the box, on that Linux. So we have a number of repos, a lot of them actually, and then there were the repos that were in charge, so they were related to the ASP, the Android distribution, and then there were others that were related to the Linux distribution. So for the Android distribution, for example, every time a change was made, we will run and we will build a new image of that Android operating system, and we will run we will flash that image into the board, so the physical board in this case, and then we will run what is called a set of CTS, which are some smoke tests that Google provide that allow you to test that your version of Android is actually working correctly. And then after that, it will go into more of an integration testing phase, where we will test the whole system as a unit and run all these end-to-end tests. And if that passes, then that's when all the artifacts will get ready to be released. The release was actually manually triggered because that was a business decision in this case. And the same thing with the Linux distribution. We were using Yocto. That's an open source platform that allows you to build Linux distributions kind of targeted to embedded systems, so it's really lightweight. And the good thing about Yocto is that you can create recipes, and in code you can define what are the layers that you want in that distribution. So automating all of that process is very, very easy. And yeah, so that's what we were doing in that respect. And so the thing with this was that, the Android operating system and the Linux one, they are massive. They're really big things, right? So actually compiling them and building them and creating the artifacts was a really huge task. And it required a lot of memory, a lot of computational power. So, it will take up to, 10 hours, very, very long process. So, you can't go and tell someone that, continuous delivery is the best and it's going to give you this greater feedback, and you need to just think on the smallest thing that you can commit, just one line of code, and then wait for 10 hours and you will see how awesome that is. So no, that's not happening, right? So we kind of started looking at how we could improve the overall time that will take for us to run this pipeline. So we use a lot of AWS, and I think we use it in a very clever way, and I'm assuming that you can do the same with Google Clouds or with any other cloud provider. So we had an EC2 instance, a medium instance, very cheap, to host our Jenkins server, and also has a Jenkins agent just for very small tasks. And then we had 2 massive instances to build and deploy and create the artifact for the 2 big distributions that we needed. And what we did was we used Jenkins as a plugin, an AWS plugin, but anyway, you can do this through the Amazon CLI. So these big machines, were only used when a specific stage of the pipeline was triggered. Excuse me. So we were only using them for a maximum of 4 hours per day. So we were able to reduce the cost massively and also reduce the time massively. So we were able to do the end-to-end pipeline in under an hour, less than an hour. We have also a Jenkins instance that was on premises, so we could have our devices plugged and we can run the system tests, but the whole thing works as a unit altogether. The other thing that we did was we used also Docker extensively. So all of the builds were built on a Docker container, and those Docker images were already packed with the tool chain and any other library and setting that required to build all of these things. And then everything was stored in a S3 bucket, so it was easily accessed by everyone. So yeah, I think that gave us a big win. That gave us a lot of traction and a lot of trust from the company and the teams. And we really move things along once you start showing them that you can do things, and it doesn't need to cost you a lot. There are other things, actually. This is so you can utilize the clouds or for any other of the developments that you're doing with IoT, like AWS and Google have an immense set of resources and services that you can use that can help you to manage messages between your devices or security or data. So, there is a point of how much of that can I outsource to a cloud provider while I kind of focus on getting that value out the door quicker. There is also a lot of innovation in this space. One of the things that we didn't do, but is really promising, is a tool called Resign.io that is now being acquired by Balena, which is a platform or is a tool that allows you to deploy deploy Docker containers to IoT devices. So you can now do deployment at scale. Which is, the type of innovations that we are seeing right now, and we will keep seeing in the coming months and years, how we can improve and how we can improve the processes and how we can work into having the nodes for just one device that I have in my office to the tens of thousands of devices that are going to have spread along the wall. Moving now into actually releasing the software or releasing the hardware. Obviously, these are complex systems, and as we said before, the hardware and the software will follow different life cycles, and they will also follow different pace, right? So this is an example of a car. Like manufacturing a car, a new model of a car takes years, but the software that your car is running could be deployed and could be updated many times per day, right? So being able to separate as much as possible all of these moving pieces can help you to accelerate the value that you want to provide. In our case, as we were still on the development phase, so the car or the system was not in a physical car being used by customers. We have a different kind of time frame, but we still have some hard deadlines that we need to target. So every 6 weeks, there was a new version of the boards that need to be shipped and released into staging, I guess, because it wasn't production, but it was on the hands of someone else. So we did that. That was done, but we were able to release software every 2 weeks, and even in some occasions with more frequency every week. And that also helped a lot to change the conversation between a company that is very used to look at their delivery into months of stuff to do, to actually start looking at very more shorter term and adapt and learn and improve. So last but not least, organizational alignment. And as I was hinting just now, that's definitely one of the hardest parts to do. Not only, I guess, when you are trying to improve on continuous delivery practices, getting the buy from everyone in the organization is the most difficult thing to do, not only for any type of project, any type of company, actually. But this talks a lot about breaking silos, so having operations, having QA teams coming into play much early on, or working even with the teams, so having kind of fully cross-functional teams, creating a culture that is based on feedback, that is based on automation, that is based on quality, and that can help you start delivering all of this value. One of the things that I also found super useful when I was doing this was also to get people excited about the idea of automating stuff, and also bring people who have the knowledge, who can champion all of these practices and can help you to just spread that knowledge and help other people get better at that. And yeah, and that's me. Thank you. Any question?
Hi, thanks for the talk. It was very useful. You mentioned you had kind of like the Linux-based application and the Android-based application.
Yeah.
So when a commit in a single repository triggered the whole pipeline process, did you run the whole end-to-end test for that specific commit, or did you group them together trying to minimize the times? Because I saw the 2 big Jenkins agents that you had in production. I guess that was the meaning of them.
Right. So if there was a chain on the, let's say on the, so when you say HMI image, that's basically the one the board that was running on the box. So if there was a chain in there that will run the test on that specific device, and it will create a new artifact of that one, and then it will run system tests with the previous artifact of Android, but it won't trigger a new one. No.
And when, more on the delivery side, when you had a single application that wanted to be, I don't know, promoted to production, that would be tested against the rest of the system previous stable version altogether, just trying to minimize where the deltas were.
Yeah. So the key about continuous delivery is that you build it once and then you test it multiple times. So the artifact was only built when there was a chain of that, and then that artifact was used to test different things in different stages. And if only this artifact was the one that changed, then only this artifact will get rebuilt. This other one will stay the same as it was since the last commit. So we ended up, the ASP was really easy to build. We only have a few things that we need to tweak. So we ended up having a very stable version of that ASP very early on. And for most of the time, what we were changing was the Linux running on that box. So,
Thank you.
Cool. Okay. Anyway, I'll be around. If you have any questions, you can come and talk to me now or later at the ThoughtWorks booth. Yeah. Cool. Thank you.